So good afternoon everyone, I'm Fan Zhenkong, and today I'm going to discuss the topic of the shadow copy and the deep copy. So let's begin with a piece of code. What will the result be for this code? Well, it's very simple, right? The a equals to 0, and you set the value of b to a, and so b will be 0 at first output, and you set a to 1, but it will not influence the value of b, so at the second output b will still be 0, so the final answer will be 0 and 0. Okay, let's see another piece of code. What's the result be? Well, for those who hasn't taken the EECS280, they may say, okay, at first b equals to a and a equals to 3, so in the first output b will be 3, and if you change the value of a or delete a, those behaviors will not influence the content of b, so the content of b will still be 3, so it will be 3, 3, 3. But fortunately we have already taken the EECS280, so we know the answer is wrong, right? So what the answer will be? It will be 3, 1, and undefined behavior, right? So let's analyze actually what makes this result. So it actually is caused by the shadow copy, right? So what's shadow copy? So at first we have a pointer a points to the object a. In this case it is an integer 3, and we set the b equals to a. What does that mean? Actually it assigns two pointers points to the same object, that is integer 3, and the content of b is actually the object a, so at the first output it will be 3, and if we change the values of a into 3, then in the second output we output the content the pointer b points to, which is still the object a, so it will output a. After we delete the a, we access the memory through the pointer b, then we know it is undefined behavior. And one common mistake is that some people may think if you delete a memory it will be reset to 0. That's not correct. Actually it may be anything. It may be 1, it may be -1, and it may be some odd number. It's just undefined behavior. So what is the right way to do if we want to let the pointer a and pointer b does not influence each others? So we can do the deep copy. So by saying deep, actually it means we allocate a new memory and copy the object itself. So here let's say we instantiate object a, and we instantiate an object b with the same value of the object a. And here, no matter what behavior or what options we do on a, it will not influence the object b. But one thing you need to notice is that you need to delete b at last, because you allocate new memory to it, right? What error will cause if we do not have the last line of our code? It will cause the memory leak, right? And if you call this f3 many times, and it will make the program cause a runtime error, because you just have too many memories that is not free. And the shadow copy and the deep copy actually does not only exist in C++. They exist in many other languages like Python. Well, for those who have already taken the EECS280, it may surprise you guys, because the Python actually does not have the concept of the pointer. But let's say this piece of code, a equals to 1, 2, 3, and you set b equals to, you set the b equals to a. And if you change the value of a, you see the value of b actually is changed. Well, the reason for these things happen is that the variable in Python is actually reference. Yes, just like the reference in C++. And there are some operations in Python are shallow copy, and some of them are deep copy. In this case, if you want a deep copy, you can use the append method or use copy.deepcopy. But you need to be aware that shallow copy and deep copy exist in many languages, not only in C++. And actually, the deep copy and the shallow copy have many applications. The copy constructor and the overload of the operator equal signs use the deep copy, and we will discuss those things later in the following weeks. And shallow copy actually has its own usage. If you make some changes in other functions and you want to reserve those changes of variable, how can you do that? You can pass a pointer, right? Even though the pointer is destroyed after the function, but the content it points to has been modified, and you can still access that content through other pointers.